Hello everyone, my name is A. Srinidhi. I am currently pursuing BE in Computer Science Engineering at Kongonadu College of Engineering and Technology. I am going to share my views on interprocess communication. What is interprocess communication? It is a mechanism which allows multiple processes to communicate and share data with each other. The process can be running on the same system or across a network. Since processes have separate memory spaces, it provides a way for them to exchange information efficiently. And next, it is the why IPC is important. It is important because it controls the process coordination, which ensures multiple processes work together without conflicts. It allows data sharing. It allows processes to exchange information without duplicating data. Performance optimization. It enables faster execution by reducing redundancy. Next is synchronization. It prevents race conditions and ensures data consistency. Next is need for IPC. The IP is needed for process need to change data for multitasking and efficient resource sharing and coordination. And next is the synchronization between process. Types of IPC mechanism. They are shared memory, message passing, pipes, sockets, signals, etc. And the last one is shared memory. The shared memory is process share a common memory space. It leads with high-speed communication and it requires synchronization. For example, semaphores, mutex. Mutex means mutual execution. And next is two processes accessing a same memory region is known as shared memory. The code snippet for shared memory is creating shared memory in C using SHMZ and SHMET. Next one is message passing. A message passing deals with process communicate by sending and receiving messages. It requires more secure than shared memory but slower implementation via system calls. An example of message passing diagrams are two processes sending messages via message queue. The code snippet for message passing is message queue example in C program. Next is pipes and IPC. It deals with unidirectional communication channel between processes. There are two types of pipes in IPC. They are FIFO and anonymous pipes. They are commonly used for parent-child process communication. The parent process writing, child process reading. The code snippet for is creating a pipe using pipes in C. The next one is sockets in IPC. Circuits in IPC deals with communication between processes over a network. That is, the types of circuits in IPC are TCP circuits, transmission control protocol circuits, UDP circuits, which are used in client-server application, which is also known as producer-consumer applications. The types of TCP, as I said above, are TCP circuits, UDP circuits, which are used in client-server applications. And diagram is the client-server architecture using sockets. The code snippet for sockets in IPC are creating a simple TCP socket connection. Next is signals in IPC. The signals in IPC deals with software interrupts sent to a process. For example, SIGCALL, SIGSTOP, SIGTERM, etc. This is used for process control. For example, kill signal deals with the signals in IPC. The diagrams for signals in IPC are process receiving and handling a signal and code snippet using signal in C to handle signing. And the next one is the diagram to approaches to interprocess communication. They are process P1, shared memory, process P2 and kernel for the shared memory, and message queue deals with process P1, process P2, message queue and kernel. The next one is ICP, which deals with pipes, message queues, FIFO, shared memory, message passing, direct communication and indirect communication. These all deals with ICP. Why synchronization is important in IPC? Synchronization is important in IPC because data consistency and conflict avoidance are ensured via synchronization. Why synchronization is important in IPC? Synchronization is important in IPC because data consistency and conflict avoidance are ensured via synchronization when different processes access common resources. The next one is what are the main methods of IPC? The main methods of IPC are message passing and shared memory are the two main techniques involved in the main methods of CPU. IPC. While message passing permits communication without the need for shared data, the shared memory permits process to share data direct. Benefits of the IPC. IPC speed up the execution of tasks. It ensures that tasks run correctly and in the order that were executed. IPC allows different programs to be in parallel. And the next one is how IPC works. IPC uses communication mechanism and protocols to exchange information. These mechanisms include shared memory, message passing, pipe sockets, and remote procedure calls RPC. IPC can be synchronized or asynchronized. It helps processes synchronize their activities, share information, and avoid conflicts while accessing shared resources. And the next one is real-world applications of IPC. Web servers using sockets for communications, database system using shared memory for caching, microservice communication via messages queue, web servers using sockets for communication. And the next one is challenges in IPC. Security concerns in shared memory, performance bottlenecks in message passing, deadlocks in synchronization mechanism are the challenges in IPC. And the next one is these challenges in IPC. They are performance overhead, context switching, that is frequent IPC call entry, CPU overhead, message copying, data transfer between process can slow down performance. For example, copying data in message queue, resource contamination, multiple process accessing shared memory may cause bottlenecks. And next one is conclusion. A fundamental component of contemporary operating system is the interprocess communication, which allows processes to efficiently coordinate operations and share resources and communicate. IPC is beneficial for developing adaptable and effective systems, which is despite its complexity and possible security threats. Thank you.